How can plastic on the sea surface affect our climate? Plastic particles from packaging, personal care products, synthetic clothing and many other applications are a potential risk to the ocean's health. Tiny light particles from plastic can float on the sea surface for a long time. The sea surface is a special place. It is rich in chemical compounds produced by marine organisms below. Sometimes these substances make the sea surface appear as a shining, darker or brighter layer. The sea surface also connects the ocean and the atmosphere and controls important exchanges between those two systems, including the flow of oxygen, which is an essential element for life, and the flow of carbon dioxide, one of the main gases responsible for climate change. Plastic particles can increase the amount of chemical compounds in the sea surface layer. Because marine microorganisms like bacteria may be more productive in the presence of plastic particles than they are in plastic-free environments. This increased production and bacterial activity can reduce the oxygen content of the water. The surface of the ocean. The ocean has different zones and the surface layer has special properties that make it different from the water just a few centimeters below. If it only presents a small volume of the whole ocean, here is why this thin layer is so important. The ocean covers almost 70% of the Earth's surface. This means that 70% of the Earth's surface is the ocean surface. The ocean surface is in an important position because it connects two systems, the water and the air. Since it is in the middle, the sea surface mediates all exchanges between the oceans and the atmosphere. We think that the sea surface layer may also be very important for the world's climate. To understand why, let us step back and look at the circle of life in the ocean. Microlife in the ocean, the carbon cycle. Phytoplankton and bacteria are a small marine organism that support all life in the ocean. With only sunlight and carbon dioxide, phytoplankton can produce sugars. This process is called photosynthesis. Sugars contain carbon and hydrogen atoms and are therefore called carbohydrates. If you want to know more about sugar, then you can watch my sugar video, which link in the description. Carbohydrates are the building blocks of living things. Phytoplankton also produce oxygen. About 70% of the oxygen that we breathe comes from these tiny plant-like creatures in the ocean. Bacteria consume and transform the carbohydrates and oxygen generated by phytoplankton. In this process, the bacteria put carbon dioxide back into the water, the sea surface and finally the atmosphere. The biogeochemical carbon cycle in the ocean. Carbon moves between living things and non-living things from the atmosphere in the form of CO2. Carbon is absorbed by phytoplankton and incorporated into glucose in the process of photosynthesis, which contemporarily produces oxygen. Through photosynthesis, these marine creatures can produce up to 70% of the oxygen that we breathe. In seawater, bacteria consume carbohydrates and get energy. In this process, bacteria re-aspire using oxygen and releasing CO2. They also transform carbohydrates into other compounds. This way, carbon now travels through the bacteria into organic matter and then back to CO2 as it moves again to the atmosphere. From tiny microbes to large whales, all forms of marine life rely on this cycle, which is known as the biogeochemical cycle of carbon. In perfect conditions, the production and consumption of oxygen and CO2 are in balance. Plastic on the sea surface. Unfortunately, there are bad materials on the sea surface too. Most originate from man-made pollution, and one of the most common is plastic. Plastics play a fundamental part in our everyday lives. However, many of the single-use plastics we use, like plastic bags, takeaway cups and lids, plastic straws, end up in the sea where they do not belong. Plastics were already floating in the ocean almost 50 years ago. The plastics found on the sea surface are usually light, small particles less than 5 mm called microplastics, which can float in this marine compartment for a long time. However, more than 80% of the plastic in the ocean comes from land, rivers, households and mismanaged waste. Let us imagine what happens at sea surface. We have lot of organic matter and many active bacteria transforming it and producing CO2. Then comes the plastic. Since bacteria cannot swim but are carried by the currents, any particle big enough for the bacteria to attach to will provide a place for them to live. The more places to attach, the more bacteria will end up living in that environment. More bacteria means that more oxygen will be used and more CO2 will be produced. Plastic in the ocean may contribute to climate change. The presence of microplastics in the sea surface is a serious problem that can interfere with fundamental biological processes. These processes control the flow of important gases like oxygen between the surface and the atmosphere. Using oxygen, bacteria transform organic matter in the seawater and in the process produces CO2. When there is a lot of plastic present, bacteria consume more oxygen. This is a problem because less oxygen will be available for other life. The ocean is the Earth's blue lung. If we reduce its capacity to produce oxygen, we will change how this lung works. This is a problem because when there is a lot of organic matter on the surface of the ocean, the flow of oxygen from the ocean into the atmosphere might slow down. The flow of carbon dioxide from the atmosphere into the ocean might slow down as well. This is an even bigger problem because our oceans are one of the prime sinks of CO2, meaning that they absorb a lot of carbon dioxide that humans emit to the atmosphere through fossil fuels combustion, and that in existence cause of the greenhouse effect and global warming. If the ocean takes up less CO2, the Earth could face unimaginable changes in its climate. The amount of plastic in our oceans is gigantic and keeps increasing. Therefore, we need to think hard about the consequence of increasing amounts of plastic in our rivers and oceans. It is important for all of us to join together with our families, friends, scientists, and society to find solutions to this global problem.